NEC 430.110 states disconnecting means shall be provided to disconnect all ungrounded conductors of branch circuits and feeders to motors and shall be located in sight of the motor they supply. NEC 430.110 states motor disconnecting means for motor controllers not capable of being locked in the open position shall be interlocked with the controller to prevent starting of the motor when the controller disconnecting means is opened. NFPA 120.5H states lockout tagout procedure shall not render inoperable the means for normal emergency stopping, interlocks, limit switches, or other safety devices. When the motor disconnect is required to be located more than 50 feet from the controller, the motor disconnect must be interlocked with the controller circuit to prevent unexpected startup. This interlock can be achieved using an auxiliary contact in the motor disconnect that opens the control circuit when the disconnect is opened. Lockout-tagout procedures do not permit the omission of the interlock between the motor disconnect and the motor controller circuit. This is because the interlock is considered a safety device that prevents unexpected startup of the motor. Therefore, the motor disconnecting means must disconnect the control power in its entirety to the motor control circuit via an additional contactor at the controller's control power transformer or by two auxiliary contacts within the motor disconnecting means. The interlock is necessary to prevent the following scenario. The motor disconnect is closed after maintenance is completed. Someone initiates the start command, pressing the start button, and walks away. Later, the motor disconnect is closed again, inadvertently starting the motor. To meet code requirements and prevent unexpected motor startup, the motor disconnect means must be interlocked with the motor controller circuit when the following conditions are met. Firstly, the motor controller cannot be locked in the open position. Secondly, the motor disconnect is located more than 50 feet from the controller. And thirdly, lockout-tagout procedures must not render the interlock inoperable. For multiple stop-start locations, additional motor disconnects may be required to meet the 50-foot rule. These disconnects should also be interlocked with the controller circuit. The interlocking scheme should be designed to ensure that the motor cannot be started if any of the disconnects are opened. Let's delve deeper into the requirements and best practices for motor disconnect interlocks. First, let's clearly define what a motor disconnect is. It's a switch designed to isolate a motor and its controller from the power supply. This isolation is crucial for safety during maintenance, repairs, or any time the motor needs to be de-energized. Now, the 50-foot rule, as it's commonly called, stems from NEC 430.110 which generally mandates that the disconnecting means be in sight of the motor and the driven machinery. The intent is to allow the operator to clearly see that the motor is isolated before working on it. However, when the disconnect isn't within sight, specifically when it's more than 50 feet away, additional safety measures become necessary. This is where the interlocking requirement comes into play, as specified in NEC 430.110. The interlocking mechanism is designed to prevent the motor from starting unexpectedly when the disconnect is opened. Think of it as a safety net. It ensures that even if someone inadvertently tries to start the motor while the disconnect is open, the motor won't actually start. How is this interlocking achieved? One common method is using an auxiliary contact within the motor disconnect switch. This auxiliary contact is wired into the motor controller circuit. When the disconnect is opened, the auxiliary contact opens, effectively breaking the control circuit. This prevents the motor starter from energizing, even if the start button is pressed. Now let's talk about lockout-tagout, often abbreviated as LOTO. LOTO procedures are critical for ensuring worker safety during maintenance and repair. These procedures involve de-energizing the equipment, applying a lock to the disconnecting means, and attaching a tag indicating that the equipment is out of service. The key takeaway here is that LOTO procedures must not disable any safety devices, including the motor disconnect interlock. As NFPA 120.5H clearly states, lockout-tagout procedures shall not render inoperable the means for normal emergency stopping, interlocks, limit switches, or other safety devices. The interlock is considered a vital safety device. It's there to prevent unexpected motor startups, and bypassing it would create a dangerous situation. Therefore, the motor disconnecting means must disconnect the control power in its entirety to the motor control circuit. This can be achieved in several ways. Firstly, by using an additional contactor at the controller's control power transformer. This contactor is wired in such a way that when the motor disconnect is opened, the contactor energizes the entire control circuit. Secondly, by using two auxiliary contacts within the motor disconnecting means. One contact would open the control circuit as described earlier, and the other contact would disconnect the control power transformer. The goal is to completely isolate the control circuit when the disconnect is open, preventing any possibility of accidental motor startup. Let's consider a scenario to illustrate the importance of the interlock. Imagine a maintenance worker completes repairs on a motor. They close the motor disconnect. Unbeknownst to them, someone had previously pressed the start button and walked away. Without the interlock, the moment the disconnect is closed, the motor would immediately start, potentially causing serious injury or damage. With the interlock in place, the motor will not start. The control circuit is broken, preventing the motor starter from energizing. This gives the maintenance worker time to recognize the situation and take appropriate action. What about situations where there are multiple start-stop locations for a motor? In these cases, additional motor disconnects may be required to comply with the 50-foot rule. Each of these disconnects should also be interlocked with the controller circuit. The interlocking scheme should be carefully designed to ensure that the motor cannot be started if any of the disconnects are open. This might involve using a series of auxiliary contacts wired in a way that breaks the control circuit if any one of the disconnects is opened. When designing and implementing motor disconnect interlocks, it's crucial to consult with qualified electrical engineers and adhere to all applicable codes and standards. This is not a place for shortcuts or guesswork. Safety must always be the top priority. The interlock is not simply a convenience, it is a critical safety device that protects workers from potential harm. Let's recap the key points. Firstly, NEC 430.110A generally requires a motor disconnecting means to be in sight of the motor within 50 feet. Secondly, NEC 430.110F mandates interlocking when the disconnect is not in sight and the motor controller cannot be locked in the open position. Thirdly, NFPA 120.5H prohibits lockout tagout procedures from disabling safety devices, including motor disconnect interlocks. Fourthly, the interlock must completely disconnect the control power to prevent unexpected motor startups. Fifthly, additional disconnects and interlocks may be needed for multiple start-stop locations. And sixthly, always consult with qualified professionals and adhere to codes and standards. By following these guidelines, you can ensure a safe working environment and prevent potentially dangerous accidents. Remember, electrical safety is everyone's responsibility. Understanding and implementing motor disconnect interlocks is a crucial step in protecting workers and preventing unexpected motor startups. To further elaborate on the practical implementation of these interlocking systems, let's explore some specific wiring configurations and control circuit designs. The most common method involves utilizing normally closed auxiliary contacts on the motor disconnect switch. These contacts are wired in series within the motor controller's control circuit. When the disconnect is in the closed or on position, the auxiliary contacts remain closed, allowing the control circuit to function normally. However, when the disconnect is opened to de-energize the motor, the auxiliary contacts also open, interrupting the flow of current in the control circuit. This interruption prevents the motor starter from energizing, even if a start command is initiated. To ensure complete isolation of a control power, a separate contactor can be installed in the control power transformer's primary or secondary circuit. This contactor is controlled by the motor disconnect switch, typically through another set of auxiliary contacts. When the disconnect is opened, the contactor de-energizes the control power transformer, effectively removing all power from the motor control circuit. This approach provides an extra layer of safety by completely eliminating the possibility of any residual voltage or current in the control circuit. In situations where multiple motor disconnects are required, the interlocking scheme becomes more complex. One approach is to wire the auxiliary contacts of all disconnects in series within the control circuit. This ensures that if any one of the disconnects is opened, the control circuit is interrupted, preventing motor startup. Another approach involves using a control relay that monitors the status of all disconnects. The relay is energized only when all disconnects are closed. If any disconnect is opened, the relay energizes, interrupting the control circuit. When designing these interlocking systems, it's crucial to consider the specific characteristics of the motor and the control circuit. Factors such as the motor's horsepower, voltage, and starting current, as well as the control circuit's voltage and current requirements, must be taken into account. The selection of appropriate auxiliary contacts, contactors, and relays is essential for ensuring reliable and safe operation. It's also important to properly label all components and wiring to facilitate troubleshooting and maintenance. Clear and concise documentation of the interlocking scheme is crucial for ensuring that future modifications or repairs are performed correctly. Regular testing and maintenance of the interlocking system are essential for verifying its functionality. This includes visually inspecting the wiring and components, testing the operation of the auxiliary contacts and contactors, and verifying that the control circuit is properly de-energized when the disconnect is opened. Any defects or malfunctions should be promptly addressed to prevent potential hazards. In addition to the technical aspects of interlocking systems, it's also important to emphasize the importance of proper training and awareness. Workers should be thoroughly trained on the operation and purpose of the motor disconnect, interlocks, and the lockout tagout procedures. They should understand the potential hazards associated with bypassing or disabling the interlocks and the importance of following all safety protocols. Regular safety meetings and refresher training can help reinforce these concepts and ensure that workers remain vigilant about safety. It's also important to foster a culture of safety within the workplace. This includes encouraging workers to report any safety concerns or potential hazards and providing them with the resources and support they need to work safely. Management should actively promote safety and demonstrate a commitment to creating a safe working environment. In conclusion, motor disconnect interlocks are a critical safety feature that prevents unexpected motor startups and protects workers from potential hazards. By understanding the code requirements, implementing appropriate interlocking schemes, and following proper lockout-tagout procedures, you can create a safer working environment and prevent potentially serious accidents.